Weathering is a fundamental process that shapes our planet's surface, breaking down rocks and minerals through both mechanical and chemical means. But what exactly is weathering and how does it differ from erosion? While weathering refers to the breakdown of rocks in place, erosion involves the movement of those broken down materials by agents like water, wind, or ice. Understanding weathering is crucial for civil, environmental, and geological engineers, as it affects the stability of structures, the formation of soils, and even the creation of landscapes. In this video, we'll explore the different types of weathering, their real-world impacts, and the factors that control how and where they occur. Let's start by looking at why weathering matters and how it fits into the bigger picture of Earth's dynamic system. Mechanical weathering breaks rocks into smaller pieces without changing their chemical composition. There are four main types: frost wedging, salt wedging, exfoliation, and root wedging. Frost wedging occurs when water seeps into cracks, freezes, and expands, splitting rocks apart. Salt wedging happens as salt crystals grow in rock pores, exerting pressure and causing fractures. This is common in coastal or arid environments. Exfoliation, or pressure release, involves rocks expanding and fracturing parallel to the surface as overlying material is removed. Finally, root wedging is when plant roots grow into cracks, forcing rocks apart. Each of these processes can dramatically alter landscapes and even damage infrastructure such as roads and buildings. Let's look at some striking examples and see how these forces shape our world. Chemical weathering involves the breakdown of rocks through chemical reactions, often with water and atmospheric gases. The main types include dissolution, hydrolysis, oxidation, and hydration. Dissolution occurs when minerals like calcite or gypsum dissolve in water, sometimes forming features like sinkholes. Hydrolysis transforms minerals such as feldspar into clay minerals through reactions with acidic water. Oxidation is the reaction of minerals with oxygen, often turning rocks reddish due to iron oxidation. Hydration involves the absorption of water into mineral structures, causing expansion and breakdown. These processes are especially important in forming soils and releasing nutrients, but they can also lead to structural problems, as seen in the Quebec pyrrhotite crisis. Chemical weathering is influenced by factors like mineral composition, temperature, and moisture, making it a dynamic and complex process. Rate and extent of weathering depend on several key factors: the presence of faults and fractures, rock porosity, surface area, climate, and mineral composition. Faults and fractures allow water and roots to penetrate deeper, accelerating weathering. Rocks with high porosity are more susceptible as water and gases can easily enter. Smaller particles have a higher surface area to volume ratio, making them weather faster. Climate plays a major role. Mechanical weathering dominates in cold, wet environments, while chemical weathering is more intense in warm, moist regions. The products of weathering include sand and gravel from physical processes and clay and dissolved ions from chemical processes. These materials are vital for soil formation, sedimentary rock creation, and even economic resources like clay and sand. Understanding these controls helps us predict landscape evolution and manage engineering challenges.